A fisherman off the coast of Japan hauls in his net at dawn. Something is thrashing inside it, translucent skin, pin-thin teeth, veins visible through flesh that looks half melted, milky eyes already going blind in the light. This animal should be alive 800 meters below him, in cold black water under pressure that would crush a car. Instead, it is dying on wet wood in the pink morning air. A monster from the deep. That is what the headlines will say. That is the click. And somehow, that is not the strangest part of this story. The strangest part is not that they are rising, it is what is not rising with them. You are not looking at a discovery, you are looking at a body. In the last few years, marine biologists have been quietly collecting reports that do not fit a normal pattern. An oarfish washed up on a Mexican beach, silver and unreal, nearly 6 meters long. A frilled shark filmed alive in shallow Australian water, an animal so ancient it looks like it swam out of a museum. Dead viperfish appearing on shorelines, goblin sharks caught in nets meant for shallow tuna. Sixgill sharks, giants of the deep, cruising close enough to divers to be filmed. Different species, different oceans, same direction, up. The obvious explanation is the exciting one. The deep is sending its monsters to the surface. That is the story people want, because it feels like a movie. But the environment tells you what killed them before anything else does. Picture a mountain climber found in the snow wearing shorts. You do not need to guess what went wrong. The mismatch is the whole story. These animals are not built for the world where they are showing up. Their bodies are collapsing on contact with it. Every stranded oarfish, every dead viperfish, every rare surface sighting is not a miracle. It is an autopsy. They did not come up to visit, they came up because they could not stay. Which raises a stranger question. If the surface kills them this quickly, why are they leaving the place that keeps them alive? To answer that, you have to stop thinking of the ocean as one big blue space. That is the surface myth. The truth is the ocean is a stack, a sunlit layer where photosynthesis works, a twilight zone below it, dim and cold, a midnight zone, no light at all, only pressure and hunger. And beneath that, the abyss, where sunlight has never touched anything for as long as animals have existed. Roughly 90% of the ocean, by volume, is in those darker layers. That is where the story of Earth is actually happening. And that is where nobody is watching. Picture an invisible layer of life the size of a continent, rising every night and sinking every dawn. That is not a metaphor, it is real. Every evening, when the sun goes down, trillions of small animals in the twilight zone begin to climb toward the surface to feed under the cover of darkness. Then, before sunrise, they retreat back into the black. It is the largest daily migration on Earth, and it is invisible from the deck of any ship. Early submarines used to bounce sonar off it and get a false reading. The seafloor seemed to move up and down. It was not the seafloor. It was a living layer thick enough to fool their instruments. That layer is not the deep. It is not the surface. It is the middle. And that is what is changing. Not the surface, not the deep. The middle. The creatures we keep seeing on our shores did not come from the middle by accident, they came through it. And to understand what pushed them into that ride, you have to look at what their bodies actually are. A deep-sea animal is not a tough animal. That is the most common misunderstanding. When people picture the abyss, they imagine armored monsters, evolved for a hostile world. The truth is almost the opposite. Deep-sea creatures are the most fragile specialists on Earth. Their flesh is often gelatinous, their skeletons are soft, sometimes barely there. Their muscles are watery. Their eyes are tuned to a specific wavelength of dim blue-green light that only exists in a specific band of depth. Their blood proteins only function in cold. Their cells are stabilized by chemistry that only works under crushing pressure. They did not evolve to survive. They evolved to fit. There is a difference, and the difference is fatal. A perfect fit means zero flexibility. Move one variable and the animal breaks. Warm the water a few degrees and its enzymes falter. Reduce the pressure and the proteins in its cells stop folding correctly. Change the oxygen and its slow metabolism cannot compensate. These are not creatures you can rescue by scooping them into a nice, cool aquarium. Most of them are already dying by the time they leave their lair. Which means when you see one on a beach, you are not looking at an invader. You are looking at the last few minutes of an animal that had run out of options. Something down there ran out first. The first suspect is invisible. It has no color, it leaves no wound, and it is spreading through the ocean like a slow smoke. Research suggests the ocean has been quietly losing oxygen for decades. Not everywhere at once, and not by huge amounts in absolute terms, but in a way that matters biologically. Roughly since the 1960s, dissolved oxygen levels in large parts of the mid-ocean have been trending down. Oxygen minimum zones, the layers where oxygen is naturally low, are expanding. They are getting thicker. They are pushing upward and outward. In some regions, they now sit close enough to the surface that the animals living below them are running out of the layer they were built for. Imagine your house filling with smoke, one floor at a time. You go up the stairs to breathe, then to the roof, then over the edge. That is not aggression. That is the last step. The surface is not a target, it is the last step. Layered over the oxygen problem is a temperature problem, and the temperature problem is worse than most people think. The obvious version is that surface water is warming. That is true, and it matters. But the deeper effect is what warming does to the vertical structure of the ocean itself. Warm water is less dense. It sits on top of cold water like a lid. And when that lid gets warmer, the ocean stops mixing the way it used to. Think of it like a saucepan on the stove. The top layer heats and boils. The bottom stays cold. Nothing rises, nothing sinks, nothing exchanges. In the ocean, that stratification means less oxygen from the atmosphere gets pulled down to the mid-depths, and fewer nutrients from the bottom get carried up. The whole vertical breathing of the sea slows down. The ocean stopped breathing in and out. It started holding its breath. Cold-adapted deep animals sit inside this shift. Their metabolisms drift as their prey shifts. Their enzymes, tuned for near-freezing water, start to misfire when the temperature nudges up. Even food, if they can find it, becomes harder to convert into energy. They can starve in a place that still looks full. And when the low oxygen band starts to press up against them from above, they face a physical choice that is not really a choice. Suffocate where they are, or climb. Some of them climb. Most do not survive the climb. Because the trip itself is the punishment. That milky eye on the fisherman's deck was not sick. It was the result of physics. A fish built for the pressure of 800 meters is a fish carrying gas, liquid, and tissue that are all tuned to that pressure. Take it up too fast, and every gas pocket expands. The swim bladder, if it has one, inflates like a balloon inside the body and can push organs out of place. Gases dissolved in blood come out of solution and form bubbles. Eyes bulge as the fluid inside them expands. Proteins, especially the ones stabilized by chemicals like TMAO that let deep animals resist crushing pressure, start to lose their shape once that pressure is gone. You can watch this happen in tanks. It is not a monster movie. It is a slow, quiet unmaking. The animal does not fight. Its body simply becomes the wrong shape for the world it is in. The oarfish that reaches a beach, the goblin shark that gets caught in a shallow net, the viperfish on the shore, these are the small percentage that survive the trip long enough to be seen. For every one that makes it visible, imagine the ones that stopped in the middle of the water column, tumbling slowly downward, becoming food for whatever is still able to eat. For every one that reached the surface, thousands stopped in the dark. But the truth is, some of them did not rise on their own. Something lifted them. The ocean has plumbing. Vast river-like currents move heat and cold, oxygen and nutrients, larvae and adults, in patterns that have been stable for so long that fishermen built entire cultures around them. The Kuroshio off Japan, the Humboldt off South America, the California current off the west coast of North America. Upwelling zones where cold, nutrient-rich water climbs from the deep and pours into the sunlit layer, feeding blooms of plankton, then krill, then fish, then everything else. When the pipes shift, everything downstream changes address. Warmer surface temperatures do not just heat water, they shift wind patterns. Winds shift currents. Currents shift where upwelling happens, and how strong it gets, and when. Off the coast of Peru, unusual warm water intrusions have collapsed anchovy stocks that had been steady for decades. Off California, the pattern of cold water pulses has become unreliable enough that seabirds have starved on cliffs, while, a few miles offshore, the sea looked normal. Off Japan, meanders in the Kuroshio have become more pronounced, throwing warm water fish into cold water fisheries and vice versa. None of these are apocalyptic on their own. Stacked together, they are a signal. In some recent years, upwelling has flared in the wrong places or at the wrong times, dragging cold, deep water and everything that lives in it into layers where it does not belong. Deep-sea larvae, drifting jellies, midwater fish, even the occasional larger predator get carried up in slow-motion elevators of misbehaving water. They do not choose the ride chooses them. Once they enter warmer, brighter, oxygen-rich shallow water, most of them will not go back down. They cannot. Their bodies have already started to fail. They drift, they gasp, they wash toward shore. Some of these rising creatures are not escaping, they are being served. And here is the uncomfortable part. Sometimes the same creature is doing both at once. Half starved by hunger below, half carried by shifting water above. Two problems layered on the same body. The animal never had a clean chance to decide anything. The ocean simply moved around it. So, on top of oxygen loss, on top of stratification, on top of warmth pressing down on cold adapted bodies, the physical circulation of the sea is nudging deep animals upward for reasons that have nothing to do with the animals themselves. The story has stopped being about them. It has started being about the machine they live inside. And that machine runs on something almost nobody talks about. If you drop a bright light beneath a research submarine at 1,000 meters, you will see something unforgettable. A soft, endless rain drifting past the beam. Flakes, threads, tiny particles like snow at night. It never stops, it never varies. It is not weather, it is food. Marine snow is what the deep ocean eats. It is the constant fall of dead plankton, fish waste, shed cells, mucus, and broken organic pieces from the sunlit layer. Every animal below the sunlit zone, from tiny copepods to giant squid to the slow ghost sharks of the abyss, either eats it directly or eats something that does. Almost every calorie in the deep sea, from the smallest shrimp to the largest predator drifting through the midnight zone, was once sunlight at the surface, then a plankton cell, then a body, then a flake of falling debris. The abyss is a downstream kingdom. It has no farms of its own. That soft rain is the entire budget of the deep ocean. Cut the snow, empty the dark, and here is where the whole story changes shape. Because the amount of marine snow that reaches the deep is set by what happens at the surface. Surface productivity, meaning how much phytoplankton blooms, how much krill grows, how many small fish feed and die, decides how much falls. If the surface produces less, or if the surface changes in the wrong way, less falls. The deep does not know about climate reports, it knows about hunger. The monster rising in the net is not hungry for humans, it is just hungry. And behind the hunger sits a bigger machine. That daily migration of trillions of small animals from the twilight zone to the surface at night, the one that fools submarine sonar, is not just a wildlife spectacle. It is one of the largest carbon movers on the planet. Those animals feed at the surface, then they dive again. Their waste, their bodies, their motion carry carbon downward, out of the atmosphere, into deep water where it can be stored for a long time. It is called the biological carbon pump, and scientists estimate it moves a staggering amount of carbon every year, though the exact number is still being refined. The largest migration on Earth happens every night, in silence, and we are watching it fade in real time. Because when the twilight zone gets warmer, or lower in oxygen, or thinner in food, that migration weakens. Fewer animals ride the elevator, less carbon rides down with them. More heat stays at the surface. The surface warms more, the middle thins more, the migration weakens more. It is a loop, and it feeds itself in exactly the wrong direction. The rising deep-sea creatures we photograph on beaches are the visible edge of an invisible collapse of a machine we depend on. That machine has been quietly moving carbon out of the atmosphere for longer than there have been humans. It has been buffering the surface for longer than there have been continents in their current shape. It is not decorative, it is load-bearing, and now the joints are stiffening. It is not the monsters we should be counting, it is the ones that stopped moving. Remember the layer that fooled submarines? That thick, living band that made sonar operators think they had found the seafloor. In some parts of the ocean, that band is not as thick as it used to be. Fisheries acoustic surveys, the same tools designed to find schools of fish, are picking up thinner, patchier signals in the mesopelagic layers. Not everywhere, not in every season, but the direction is not encouraging. We are not seeing more ocean life. We are seeing more of a smaller number of desperate species. The surface is loud with monsters because the middle has gone quiet. That is the payoff of the line from the beginning. The strangest part is not what is rising, it is what is not. Every day, less of that living layer moves. Every night, fewer animals climb. Every dawn, fewer of them return. And the sonar screens, decade over decade, look a little dimmer, a little emptier, a little more patched with silence. The story is not what came up, it is what did not. At this point in the story, it is tempting to make this a pure climate parable. Warming ocean, dying middle, monsters on the beach as a warning. That is part of it, but it is not all of it, and pretending it is would let another set of hands stay clean. Because while the ocean has been warming and losing oxygen, we have been reaching down into it. Bottom trawlers now scrape across seamounts and cold water coral gardens that took thousands of years to grow. Some of those corals were alive when European cathedrals were still under construction. A single pass of a heavy trawl can flatten them in seconds. Long lines drift through the mesopelagic layers when nothing was fished a generation ago, catching squid and midwater fish in numbers that were never counted before, because nobody was there to count. Krill fisheries in polar waters have expanded to feed farmed salmon and pet food and health supplements, pulling calories out of the base of a food web that whales, penguins, and seals depend on. Experimental fleets have tested harvesting mesopelagic fish, the tiny lanternfish and bristlemouths that form the biggest part of that midnight migration, as a possible protein and fish meal source. If those fisheries scale up, they will target the exact layer that is already thinning. Deep-sea mining companies have secured exploratory permits in international waters and started running test vehicles across the seafloor, kicking up plumes of sediment that drift for miles in currents that no one had studied closely before. The last unmanaged part of the planet stopped being unmanaged in the last 20 years. The animals rising in nets were also being hunted from below. We did not just change the climate, we reached in. And this is the part where the story stops being impressive and starts being uncomfortable. Because the deep-sea creatures now dying on beaches did not evolve for any of this. They evolved for a world that was cold, dark, quiet, low in food but stable in its rhythms, and untouched by machines. That world existed for tens of millions of years. It has changed inside a single human lifetime. Which means we have to rethink what we are actually seeing when the news posts another photo of a strange creature on the sand. We keep asking what these creatures mean. We should be asking what they are running from. Cultures along coastlines have watched oarfish wash ashore for a long time. In some traditions, the appearance of a giant silver ribbon of a fish, curling in the shallows, is treated as an omen, a message from below. Scientists have often pushed back on this, saying there is no reliable link between oarfish strandings and specific events at sea. That may still be true in a narrow sense. But in a broader sense, these animals are, without a doubt, carrying a message. Not a magical one, a biological one. They are refugees from a home that stopped working. Their only remaining option was a bad one. Appearing in our world is proof of failure in theirs. Every sighting we celebrate is a small obituary. They did not come for us, they just had nowhere else. Picture that oarfish again, not the dead one on a beach. Picture one still alive, hanging in silver ribbons in a shallow bay, calm, luminous, entirely out of place. Beautiful and doomed. There is nothing threatening in its face. There never was. Its body was built for a world we have been quietly draining. And now go back to the fisherman. Same coast, same tide, same net. Sometime later, he hauls it up in the same pink dawn light. This time there is no monster inside. No translucent teeth, no goblin shark, no sixgill. Not even the shallow fish he used to catch on a normal morning. Just water. A few strands of gelatinous drift. A single small jelly, half broken by the pull of the line. The kind of catch that used to be considered a bad day. The kind of catch that is starting to become a normal one, in more places, more often. He does not know what caused it. Neither do the biologists who take his catch data. Not exactly. Not yet. There is not one clean answer to point at. There is a stack of them. Warming water, disappearing oxygen, shifting currents, thinning mid-water life, and human hands reaching into layers that used to be untouched. They are still being pulled apart by researchers who know they are working against time. But he knows the sea used to be louder. He knows nets used to come up heavier. He knows there used to be more surprises, and that the surprises used to be alive. He knows the strange visitors have stopped arriving. He knows the empty net is not peaceful. It is quiet the way a room is quiet after someone has walked out for the last time. The deep sea did not send monsters. It sent a warning. And then it stopped sending anything at all.